Good morning, good evening, wherever you guys are. Welcome to the OTF meetup or OTF conference. Okay, and today we have a US team here. We are going to have a panel discussion on the topic of cloud and edge, and we have panel members Prem, Deepak, and Sunku, and I will ask them to introduce themselves, and we will have some question and answer sessions. And after that, any audience wants to ask questions at the end of the session, we will have sometimes maybe 10-15 minutes. So overall, we are planning to have this around 45 minutes, something like that. Hopefully, in these 45 minutes, we believe we can cover overall the landscape of the cloud and edge computing, and hopefully we can tell some advances happening, some future technology coming up in this segment. Okay, so with that, myself, I'm Krishna Kumar. I already, Prakash already introduced to me a little bit about it. I work with the Accenture Cloud at this point of time, and I am also a CNCF ambassador. We have a large meetup group at Bangalore. We used to conduct a lot of sessions. And I'm also involved with the CCACA, that's a Cloud Computing Innovation Council. We are at this point building a cloud interoperability test bed. Yes, I'm with Accenture recently. Before that, I worked with Huawei, where I led a team developed a product called Cube Edge. That product we have contributed to CNCF, and initially it went to sandbox, and later on it went to incubation. So some little bit background on edge, but we have a panel members here who knows deep down about the edge and cloud computing. So with that, I would welcome our panel members. First, I will ask Prem Sankar to introduce himself and his activities and his involvement with the cloud and edge, and we'll go one by one like that. So Prem, could you please start with?
Thanks, Krishna Kumar, and thanks, Prakash. Good morning, good evening to one and all. Okay, I'm Prem. I'm working as VP Engineering at Cohere Technologies. Cohere Technologies is startup in the United States. We primarily work on Open RAN, and we have a bunch of patents around OTFs. That's about Cohere Technologies. That's about me. I've been associated with cloud probably since cloud inception. I was the founder of India Cloud User Group, which I started way back in 2009. After that, I got into more of cloud native. I was instrumental in getting cloud native transformation, primarily for the telco space, wherein I worked with few tier 1 and tier 2 customers in order to get their, particularly the network function virtualization into cloud native technologies. I was with yet another startup before joining Cohere that was called Lumina Networks. And before that, I had a largest team at Ericsson, where I was driving SDN as well as cloud native networking. That's about me. Quite happy to meet you all, and then happy to be part of this esteemed panel. Thank you.
Thank you, Prem. Yeah, we all know that it was a short call, and we just talked to today everybody to see that how best we can utilize the time.
Right.
Hopefully in another 30-40 minutes, we'll be able to cover some of the basic things. Hey, thanks for coming. And let me go to Deepak next. Deepak.
Hi, good evening.
Good
morning, all.
Thank you.
Yeah, this is Deepak Kataria. I am a principal solution consultant at AT&T currently on my project. And we focus on work around edge computing, around orchestration, edge orchestration, edge automation. And I've also worked with Linux Foundation projects, LF Edge in particular, on behalf of AT&T, and also on the Airship 2, which is a new Kubernetes distribution that is being led by AT&T in the OpenStack Foundation. So I basically consult on both projects, and I also contribute to the AI ML initiatives. So everywhere, anywhere there is automation, how do we take it to the next level? How do we bring in machine learning? And how do we, in cases, bring in expert systems and AI, to solve complex network problems. So we make it easier to support, the services that are from 5G. And the application of this work is not only on edge, but also extends into the RAN. So around, Open RAN is the big focus area for us. So how do we basically provide edge compute for Open RAN to be able to solve some critical problems in the RAN, with respect to adaptive schedulers, uh, with respect to, MIMO cells, putting cells to sleep, and how do we look for emitter and emissions, from drones, so we avoid collision. So there are many, many applications across the spectrum in the RAN, which edge computing as a radio edge helps solve. So we address some of those as well. Now, outside of my role with AT&T, I also am the chair of the IEEE Princeton Central Jersey section, which is part of Region 1. And we organize events, where we bring, many experts. So an event like this, but we also do like a day summit where we bring experts, from different, telcos, service providers, as well as OEMs, system, silicon software vendors. And we try to basically, deliberate, talk about, the challenges that are facing, opportunities, and how we can work in the ecosystem. So,
Okay.
Yeah, that's pretty much it. Nice to be here with you guys.
Okay,
Thank you
thanks,
for having me.
Deepak. Yeah,
Yeah,
thanks. I know this was a short call, like we also discussed the same thing.
yeah.
Let me go to our third panelist. Sunku, you want to give an introduction, please?
Yeah, thanks, Krishna. Hi, everyone. My name is Sunku Ranganath. I'm based in Portland, Oregon here. I'm one of the tech leads in Intel. So currently, my role is working on service meshes, exploring service meshes for telecom applications. Have had experience in SDN and NFV for quite a few years now, dealing with OpenStack and Kubernetes, building reference architectures, and have good experience in closed loop automation and telemetry and related open source communities. So yeah, I'm generally active in LF conferences, speaking, demoing at the LF booth, like ONS or Open Source Summit or IEEE conferences. So I might have met some of you. And I also organize open infrastructure meetup in Portland, apart from being on the technical steering committee of OPNFE and contributing to some of the IEEE and HCNFE or HCNI standards. Yeah, that's briefly about me.
Oh, okay. Thank you very much. So you guys can see now we have the panelist covering pretty much RAN to 5G to AML to all the open source stacks, cloud native, and probably we'll have a good discussion. So let me start with the Prem. Prem, I mean, like you mentioned that you work with the RAN and technologies like that 5G, and could you give a brief overview like how this RAN and 5G is going to play a big role in edge computing and connecting with the cloud?
Sure. So particularly when we talk about 5G, 5G is not only just about the new radio. 5G is all about new deployment or workload model support, right? When I mention about it, typically if you look at until 3G or 4G, primarily the mobile network was meant to provide connectivity for probably voice calls as well as data, right? But now when we talk about 5G, we are talking about three broader varieties of segments. One is, we call it as ultra reliable low latency. The second one is the massive IoT, and the third one is the enhanced mobile broadband, wherein we are talking about AR, VR workloads, right? Given this fact that the same network has to provide to different type of workloads, there has to be a bit of transformation in the whole network as well as the infrastructure that has to happen, right? Particularly, let's pick up the URLLC. When we talk about URLLC, we are talking about sub 5 millisecond workaround or turn round trip time, right? in that case, how do we really get the network to provide that or meet the requirements is a question, right? So that is where the RAN is also getting the transformation thanks to Open RAN specification. Also, the cloud thanks to Edge Cloud, wherein the Edge Cloud can be closer to that of the workloads or to that of the users. By that, what happens is you will be able to reach the needed round trip time, particularly for time-sensitive network, right? So that's the step number one. Step number two is, again, the 5G network, as we speak, is not only for the telcos, even the enterprises are looking to leverage it. How? There's a lot of new innovation that's happening. One is called the private 5G or LTE, wherein we're looking to probably use private 5G technology to provide better connectivity, which means it's going to exist with Wi-Fi, and also you have private LTE to be providing again connectivity within an enterprise, right? In those scenario, again, edge plays a very, very important role. So that is where now as we move forward, the edge cloud is going to be pretty critical in order to meet some of the use cases I've explained.
I see. I see. Okay. Yeah. Cool. Cool. Okay. So I think Deepak, you mentioned that you worked with the LF Edge and a lot of projects in that foundation, right? Could you tell briefly, like, where is LF Edge standing at this point, and what are the direction they are looking for in the edge computing scenarios? Could you please?
Yeah, so I think, basically, building on what Prem mentioned, right? So some of those same things around, the ability to provide edge compute, which will be able to, serve, different types of workloads, right? Which, so, Prem mentioned about, the private 5G, LTE, mentioned about the, the ultra reliable low latency, which are like, use cases which are going to be for the industrial IoT. If you're looking at a manufacturing floor, and if you're want to control a robot arm, and, so you need very low latency, very, essentially highly reliable communication. And all of this is possible through 5G at the radio level, right? But what if the radio is fast, but your backend is slow, and you have to go all the way, to the core network, to get your processing, then it wouldn't really help you. So you need some computing in the middle, close to where the robot is operating, to be able to do, to be able to control it, and to be able to also learn, and be able to, inference at very fast rates. So you require some low latency processing, where you can actually leverage the cloud to actually learn, from the data sets that you have on the floor, manufacturing floor. But with the inference model, then can you actually deploy it at the edge, and it can cut the latency, and you can actually get that, right? The other thing is that edge plays a very big role around promoting scalability. So if you have, all the sources trying to send data to the core, you will run into network access issues to the cloud, and you won't be able to scale. So essentially, by providing capability, closer to the end equipment, we can actually scale number of data sources that you can support. Further, the issue that Edge also brings is around privacy. See, what happens is with GDPR, others, that you can't move data too far, right? So, so sometimes data is not shared. So, so Edge also helps you circumvent some of those privacy concerns by keeping the data close to where the equipment is. The other thing that is very good fit actually, which is I always like to say is like, when you talk about AI and machine learning, so it's AI and machine learning for the edge, and edge is also helping AI and ML. Now, what I mean by that is, because edge is a scarce resource, right? We don't have as much compute as you would have in a data center.
Yeah, that's
so true. You want to, right? You want to make sure that the resources are efficiently utilized. So AI/ML actually helps make sure that the edge computing resources are properly utilized. So if you have some sort of reinforcement learning model that is watching the consumption of resources and basically always trying to steer you in the direction of optimal resource consumption, then it is making the best use of whatever compute that you have, right, at the edge. So in that way, AI/ML itself is helping edge, and edge is helping AI by providing the compute and the inferencing, so you can put in devices like NVIDIA Jetson or Google TPUs or Intel Mobileus, for instance. You have Apple Neural Engine. So these engines can actually, provide that accelerated inferencing because of the capacity that's available. So they are mutually beneficial, and they help solve complex problems. Prem mentioned that, look, 5G is a very complex network because it has to support the diversity of traffic types. On one end, you have low speed sensor traffic from massive sensing. On the other end, you have very high speed ultra reliability URLLC type of traffic, and in between the two extremes, you have this enhanced mobile broadband, right? And they all have different flavors of traffic. See, unlike in networks before, right, LTE and 3G, anytime you had a new traffic profile, it was introduced as an overlay over an existing LTE. So, for example, if you want to do IoT, you would do narrowband IoT as an overlay on top of LTE. But with 5G, everything is together. They are all, and this is because of the new radio. Yeah, there's no separation. They're one network, and the new radio, the way it operates, the ability to, space carriers, being able to, leverage, low speed, mid band, high bands, it gives you the ability to handle different traffic types. So same capability, just like you had HetNet, like if you remember in 4G LTE, we had the small cells which were put in places to augment capacity, right? The small cells basically working under the umbrella of a macro cell. You can think of edge computers as like that. It's a sort of, serving the role of a high capacity, compute that you're able to bring in, uh, in the middle of a, core data center and your user equipment. So you have sort of a continuum of compute processing, if you will, some compute in the end equipment, some compute in the edge, and some compute in the core. And together, by offloading each other intelligently, by optimal workload placement, you're able to actually, gain a lot of advantage.
I see. Okay. Okay.
So,
Cool. Okay.
Yeah.
So I think you talked about the hardware devices like NVIDIA Jetson and things like that. Now we have Sunku here. He's from Intel. He's a hardware guy. I mean, you want to take it from there, see what are the things happening in the hardware world, how it is connected in the edge.
Definitely. So before I talk about hardware, if you think about, so what does the edge service need, right? So what does the application developers and service developers, what do they care about? What do they need? Right. So if you broadly, I think some of the use cases were discussed here with Prem and Deepak, but if you look at some of the constraints or some of the requirements around edge, right? So it's limited power, or you need low latency, high throughput. Or you need certain level of automation, so like one-click deploy kind of service instances, right? And security, multi-tenancy, right? So these are all quite a lot of requirements that comes around, dealing with edge and leveraging edge, for example. So if you have something like cloud, it's assumed that you have certain set of administrators, certain set of assigned folks to take care of all of this for you, and you assume you have a lot of compute at your disposal. And now with edge, right? So one of the important thing is, what can we make it? How can we make it easy for some of the service developers and application developers to in order to move the applications from cloud to edge, or write a brand new set of applications for example, V2X, or IoT or industrial IoT, right? So a lot of these methodologies, or AI ML, or video processing, image processing, so whatever the case might be. And that is where some of the enhancements and some of the innovation in hardware that you could leverage, right? So, so a lot of folks, especially in my experience, so still not completely aware of a lot of minute things around operating system features or hardware features, right? So sometimes we're still wondering, how do I best leverage my NUMA node when for my application, while there are so many other optimizations that are available. And that is where in a lot of automation or reference software, example open source software, which is openness, that is available, open network edge service software. So it's a reference stack that you can leverage to deploy on your edge data center or your network edge or your customer premise on-prem equipment. And you can automate a lot of this onboarding, security isolation, performance tuning, right? So a lot of that can be made available for you. And given the trend towards moving from virtual machines to microservices like containers and Kubernetes is being a bit ubiquitous going ahead. So how would you leverage your microservices? Uh, the concept of microservices itself is that you write in a simple chunks and easy to deploy, easy to scale. Now, how can hardware help that? Right, so that's where a lot of these accelerator devices are helping. NVIDIA, for example, has DPU, data processing units, right? So a lot of smart NICs, FPGA boards, and a lot of accelerators, various models like bump in the wire model, or a specific purpose device that are available. And that is where a generic set of APIs, a simple reference stack. If you look at OPNFV, there is a bare metal reference architecture based project called KubeRef. For example, you can deploy on bare metal and it automatically provides you all the acceleration features of your NIC, hardware, CPU, cache, everything in between. Right, so making this easy for developers and service providers, whether you're dealing with your network slicing requirements, whether you're dealing with low latency edge type requirements, high throughput requirements, so customizing your applications to make it easy and be scalable across the hardware. There's a lot happening in that space. And Akraino, for example, Akraino project has a lot of blueprints that they're publishing in order to leverage a lot of this hardware innovation, and that you can look at and enhance your deployments, for example.
Okay, cool. So everybody knows that a lot of data will be generated at the edge, right? And there is a saying that whether really edge will replace the cloud, I mean, like maximum computing is going to happen at the edge and it's not in the cloud. Is that going to happen? So I'll ask an open question, and whoever wants to answer that. Is it edge really going to replace the cloud or really going to challenge the cloud in terms of computing, data, and AI, ML, everything you can do at the edge, right? So is it really going to happen? Anybody can take the call.
Yeah, I can probably take
Okay.
it. So actually, when we talk about edge, right, there are a couple of edge, far edge, near edge, right? So the reason the edge is being brought in is essentially to cater to some of the specific needs of the workloads, as we were explaining, right? Whether edge is going to replace or not is a very important question. The reason is, you can imagine that the moment you have our cloud, which is the public cloud, right?
Correct.
We are talking about pets versus cartels, right? Wherein the cloud is talking about elasticity, massiveness, various services, right? So the cloud is going to continue to be existing and doing what it is doing today, right? The edge cloud becomes specialized cloud. The reason being, as you move away from that of the common public cloud, right? It becomes constrained because one is space constraint, another one is power constraint, which means what happens is it's going to probably load or provide service to specific type of processing and then push it on to that of the core, right? Where you're talking about scale and economics and numbers, right? Again, I believe Deepak was also mentioning to it, right? So what happens is, particularly when we talk about enterprises that has distributed sites, particularly, let's say, for example, oil companies, right? When you have rigs that are distributed, there's a lot of data that is being generated at each of these sites.
Correct.
Right? I think Deepak also mentioned it. But what happens is they have edge sites that are local to it for two reasons. One is they can process the data and send only the important information, more of aggregation to that of the core cloud, number one. Number two, what happens is there might be certain data that is quite secure. They need to have more compliance and security, right? In this case, edge cloud plays a very important role, right? And the third most important thing is, particularly when we talk about 5G, there is a concept called app placement or application placement is a very important role, right? A very simple example, take a V2X, which is vehicle, automated vehicle type of thing, right? So the automated vehicle, even though they are autonomous in nature, a lot of intelligence sits on the cloud. So when a car moves, to give an example, when a car moves, the application related to that also needs to move, right? In that case, app placement happens at the edge, right? So these are some of the examples wherein, but which quantifies that we will continue to see growth in all three types of cloud, and they are going to be existing for years to come. That's my view.
I see. Yeah. Anybody wants to chip in that? Actually, there is the debate of edge versus cloud, or is it there's a fog also there? You know, we are talking about fog computing. So it's a world out there. So
right. No, I think I'm I agree. See, what's happening is that see, previously, if you have a large data center, you're trying to service multiple endpoints. Now with edge computing, some of that is going to be offloaded, right? So essentially, because you have these large number of edges, right? Prem mentioned about far edge, near edge. There is going to be edge deployed in the enterprise, edge deployed in the central offices, close to the base station, on manufacturing floor, close to where the private operators are, your private networks are. So you see the ubiquity of these deployments, right? It's suddenly you have seen that this compute is now spread, right? So what's going to happen is that because of that, they're offloading, work that would happen in the core, right? Because so they're offloading from a compute standpoint, because now you're able to provide compute at the point of presence. The other thing is that you're also able to reduce traffic. So even the network traffic, right, the incident traffic that would travel to the core is now can be locally broken out. So they call local breakout. So you have less traffic coming into the towards the core data center. But because you have these tremendous amount of data, as you mentioned, right, Krishna, that you mentioned, the data being generated by the devices, the core can be a good place where you do a lot of training, where you have models that you can actually train which of course requires good data to train those. So all of that thing can happen there, and this trained data, when the model is trained, it can be actually pushed to these edge sites where they will just do inferencing, because you cannot do a lot of training at these edge sites which are limited in compute. so as you're saying, there's going to be
something called federated learning also, right?
Yes. So there is a federated learning, and so edge actually plays a very critical role there. What edge does in federated learning, what edge does, it doesn't require you to basically send data, to the edge. The data can be at the site, where it's being generated, but it can actually pass its model parameters to the edge. And because edge is connected to multiple endpoints, it actually can gather model parameters from multiple sites, and it can aggregate those model parameters. And after aggregating those model parameters, it can actually push those parameters back, where they're being consumed. So essentially what happened is that none of them had to share the data. Everybody's maintaining their own data, but they're that local data, but they're getting a benefit of sharing, which is happening. So for example, think of a Bosch, like a Bosch robot, which is deployed in company A, company B, and company C, right? It's the same robot from the same vendor doing same similar functions, right? So now I have training data for company A, training data for company B, training data for company C.
Right.
I have at my disposal, and I can actually aggregate this, and I can push back the new model parameters to company A, B, and C. So now company A is getting the benefit of model parameters that have been generated from data generated from B and C without even any company seeing each other data, right? So they keep the data private. So federated learning, by providing an edge compute like this, as I said, this you you get this advantage. But if you want to do like if you want to really you have train your or different use case where you require a lot of training, a lot of compute. Like for example, I'll give you, if you're looking at base stations, right? See, with 5G, what happens is that you have this massive MIMO, right? You have we're not talking 4x4, like we're talking like 256 by 256 elements, and they provide very pointed beams. So there's beam steering. So you want to make sure that you are steering your beams to where they are required, right? So they require, and also when the traffic is lightly loaded or there's not much activity on the cell, you don't want to burn power on the MIMO, feeding power to these large number of antenna cells, right?
Yeah.
So you want to shut them down,
Yep.
based on learning on when they're not required, and then open them up, when there's need for it. So all of this processing, right? It's you're collecting data from thousands of cell towers, right?
Correct.
And you have to train a model. Now you require capacity, you need to compute for that. So the data centers, backend data centers can be a place where this kind of training can happen. And once the models are trained, you have to push them back to where the tower is, where the radio edge is, which is, I would say, within 30 miles of where, if you want to make like 10 millisecond latency, your distance, right? If you calculate, speed of light, you'll be around 30 miles away from the tower. That is where your edge compute is. And that's where, from there, it has to basically be inferencing, and it has to be controlling that particular.
Makes sense. So I have traveled to China multiple times, and I have seen that their cities are with the video cameras and placed a lot of places, and it's been automated, right? Yeah. So
exactly.
you want to say something?
No, yeah, definitely a second. And so what Deepak and Prem mentioned, one way to look at this is, and it's all mainly depends on the nature of latency one, right? So you give a user low latency method of accessing any application, you would never want to go back to, so it's a method where, you have higher latencies, right? So a lot of the requirements and applications come in based on like primarily, how much latency, like what kind of latency you're looking at. That's where edge comes in. At the same time, right? So the edge, we mentioned a lot of use cases here. So there is definitely constraints that that are there, that you want the core or core of your network and or your cloud that is backing your edge to support. So it's definitely going to be in a hybrid model where edge is absolutely essential, not just for networking perspective, but in a business services perspective. Now, like businesses can now offer innovative service models. So how based on the slices, based on the amount of latency, based on the QoS or quality of experience. So there are various degrees of tiers that you can charge as a business service to end users, and Edge plays a key part in that. At the same time, you do need, for low latency, where latency throughput are not an issue, you need a backing of a cloud where a lot of that processing or intensive processing or a lot of heavy workloads can run there. So it kind of goes hand in hand. That definitely, no doubt, edge computing is a major disruption. At the same
So you
time,
work in a lot of open source technologies also, right, Sunku? So what do you think? Is it really open source going to play a big role in edge computing, or is it like a customized hardware devices which will play the role? What do you think?
No, it's a great question. Yeah, definitely. I think a lot of innovation is being driven through the open source communities, right? So whether it's LF Edge or CNDT or under CNCF, right? So this is a time where while even the core of the network or radio access network, like everybody is open sourcing like ORAN or FlexRAN. So a lot of the functionality of the network and also workloads that they're going open source. At the same time, the innovation around what the requirements should be for the edge and how can edge be leveraged. What are some of the things that are required around like how businesses can leverage edge or services should be decentralized towards edge, right? How multiple edges can be federated or orchestrated, managed. So a lot of this is innovation and requirements and standards that are happening via open source software. Right now, at the same time, who would deliver the edge, whether AWS of the world, Microsoft of the world, right? So they might deliver, they're playing a big role in actually evolving the edge right now, right? So, but then the pervasiveness is primarily due to the fact that people understand what's there in the open source world now that they can leverage, edge computing to their advantage.
I think you mentioned a lot of innovation. I think Prem may be working in a nice company where they are doing a lot of edge and RAN related. Or what are those innovations coming up, Prem? Like you don't have to reveal the secret, but what are those things coming up in the edge where which is going to make a significant difference in next few years? You have.
Yeah, sure, definitely. I think particularly from the RAN perspective, right? Thanks to ORAN Alliance, there's a standards body. They are defining how the whole RAN can be disaggregated, right? RAN, which has been mostly driven by a lot of proprietariness, is now opening up, right? What it means is, it also means that you can design your own RAN network. That is number one. Number two, there is also a concept called RAN intelligent controller. Okay, so what it does is this RAN intelligent controller serves two purposes. One is it can again collect a lot of data about the RAN network, and then you can do AI models, you can train them, and then use it for mostly aspects like self-organizing network, which is going to be a very important thing in the 5G. That is one. Second thing is also, again, as Sunku and Deepak are mentioning, the network slice plays a very important role, right? The most important driving factor of network slicing is the SLAs, right? Because the end-to-end SLA, to be more specific, which means all the way from the radio to that of your data network involving the mobile core, you have to ensure that there is an SLA that is met. In this case, what is important is you definitely need to extend your slice beyond into that of the RAN network, right?
Okay.
That is where particularly the ORAN Alliance defines the specifications, wherein even you call it as the baseband broadband unit, right? BBAs, right? The baseband unit, right? Which is attached to the radio unit. That is getting disaggregated, and which also provides the ability to control those units remotely from that of the RAN intelligent controller, so to say, right? That is one. Second thing is, particularly from a networking perspective, as all of us know, SDN has revolutionized a lot of it, right? The whole concept of data net, I mean,
software defined,
control plane and data plane separation, right? That is possible only through SDN, wherein cloud is able, networking is effective because of SDN. The same SDN concept is now applied to RAN. In case of RAN, they call it as control plane separation and user plane separation, same lines as SDN. So these are some of the innovations that's happening on the RAN side.
I see.
Again, this is happening more on a proprietary as well as in open source also. But this particular innovation is going to be redefining the whole 5G. Right? That is one innovation what I wanted to mention. And just before I end this part, there is also a concept called XApps, wherein you can build applications that's going to revolutionize. You can build applications that can be hosted on these intelligent controllers. Anyone is free to develop these applications. And what it means is more and more such applications is to come, and then more and more innovation is going to happen.
I see. Okay, cool. Yeah. So Deepak, you want to say something? Like you worked with a lot of AI ML and it's going to be in the edge. And you are also working with the IEEE and different standards are coming out of the IEEE. How does this IEEE standards, open source, and all these innovations play together in the edge? for the next few years.
Yeah, I think, yeah. So just, building what, building on what Sunku and Prem has been saying, right? So see, what has happened is this edge, as you have this edge computing and you have these computes, that you are basically that are distributed, you have created what is called a distributed cloud layer, right? So the cloud layer is distributed. So it's not no longer in the central data center, but it's actually distributed. And because you have these points of presence of edges, right? Now, now you can actually have cloud native or virtualized instances deployed at these locations, right? So now you have actually provided an opportunity for the network functions to be disaggregated, right? So so now you can have a separation. You can have a radio unit separate from a distribution unit. The U is separate, right? So now, and the central unit basically separate from the DU. It can be on a different edge edge point of presence. And then the central unit itself can be disaggregated into split into lower layer user plane and control plane, right, as was mentioned. And then the the control plane itself can be split into low level and high level control plane. The high level control plane is where the radio resource management functions are sitting. So what is now in ORAN called RAN intelligent controller is actually doing the functions of a radio resource management. So basically so now what has happened is, because you have created these edges, and these edges are hosting cloud native workloads, and these workloads are supporting either a VDU or a VCU UP or a VCU CP. You have
all kind of things.
Yeah, you have, and they're connected through open interfaces. So now I don't have a vendor lock-in. I can actually source these cloud natives functions from different vendors, and I can basically have a play. And see 5G is increasing traffic. The network provider has to make a lot of investment from a capex standpoint. So by opening this up, by disaggregating it, by consuming things from open source, to the extent possible, bringing in multi-vendor, you are able to reduce the price you have to pay for these things, right? So it helps you a little bit shoring up. And then on top of this, you bring in the AI ML. So step one, you've reduced capex. Step two is you basically bring in AI ML, you bring in operational efficiencies. Then you have some savings from an operation standpoint. Now you're able to, rather than reacting to failures, and trying to do a mean time to repair, you're actually being predictive about failures and being prescriptive proactively about mitigations. So you don't even see the failure if you design it right, and if your closed loop works very well. And that is huge savings for the operators. See, today what's happening is, if I can fault predict, right, and take action before the actual fault, I can save a lot of money.
I see. Yeah,
because right now, the ways of working was like, when the failure happens, I will try to reduce.
Then you respond after that.
And then you respond, and you're trying to reduce the mean time to repair. But with AI ML, if I can watch, I can learn, and I can predict, and I can take action before the failure, that is a huge saving for me. Okay, so that is number two, basically OpEx savings. Third thing would be new services, right? So Prem mentioned about X apps, AI apps. See, we all wait in the line for the next iPhone, right, or next Google device, right?
Yes.
Wouldn't it be nice to wait for the next cool service that the network will provide in software, right? And hardware becomes commodity, and it's just a service. How many more things you can provide.
Will Apple will agree for that?
Well, Apple may not agree for that, but I'm saying that this whole idea, if AI ML brings the power, right?
Yeah, right. True. Yeah, it will.
New services, and then you do the top line. So you have everything. You get the top line growth with new services. You get OpEx savings with AI ML. You also get capex reductions, with open source disaggregation, multi-vendor play. So all of these things together, because we need these elements to be able to support the surge of traffic that, as you said, if you have like billions of devices, massive sensing that are connected, right? Just imagine if one of them is compromised, how much risk there is to the operator, right? If there is malicious intent or malicious attach, denial of service attacks, things can get very so I have to put in place checks and balances. You have to be able to learn, train my models, and be able to react, and be able to detect these slices which may be corrupted, quarantine them, process it, take it out. So there's a lot of
lot of
good,
things are happening.
a lot of, from an innovation standpoint, it's a very fertile ground.
So,
and both IEEE Linux Foundation, they're all addressing.
All are doing actually,
Yeah.
Sunku, what do you think from a hardware perspective or a networking perspective? How does it is going to revolutionize? What is that going to happen?
Definitely. So both Prem and Deepak mentioned from perspective of workloads, for example, right? So towards 5G. Now, if we look at underlying how these workloads run, it's pretty much on the hardware, right? So off-the-shelf servers or customized servers, or whatever the case might be. But the trend is towards leveraging off-the-shelf servers, for example, right? So now, how would you differentiate your service or your deployment compared to anyone else's? How best can you leverage your hardware? For example, green computing, right? So how would you place your workloads on a green platform compared to like, so something just running in the cloud? Or how would you deal with security, key management or authentication, authorization, right? So proximity-based security, right? Role-based access control. A lot of this being offloaded to like what we have, accelerators, or there's something called quick assist technology that you can leverage, like compression, decompression, or queue management, or encryption, decryption is being offloaded to hardware. And also with respect to innovation across the cores, or how the microservices, for example, are built for and run across these hardware, right? So what are the tunings? For example, AML plays an important role here. I believe, in my opinion, telemetry is one of the least utilized feature in terms of day-to-day operations, especially hardware telemetry. Right? So if you look at various functions like real-time, near real-time, and and normal applications, right? So in terms of real-time and near real-time, you can leverage quite a bit of optimizations using telemetry and running ML models on top of that, so that you can provide an autonomous way, right, automated way of optimizing your network, optimizing your applications. Right, so there's a lot to be done there. And like I was mentioning, so microservices, the last part, right? So a lot of that is being, for example, now with SmartNICs, right? That you can have on your network interface card, you have CPUs and FPGAs on board that you can customize your processing as to data processing as to what you want to be done. For example, how service meshes could be implemented. They can leverage some of these accelerators, right, FPGA devices. So a lot of that differentiation factor is being provided by the accelerators now. And then there are many frameworks that are available. For example, one API framework provided by Intel, so that you can write your application in a simple API friendly manner, and you can deploy across multiple accelerators. And an API would help you choose that API and then be able to run it across multiple generations of hardware. So there's a lot of innovation across the hardware layer. Not only that, across the API layer through which the microservices can leverage these innovations. Yeah.
Okay, cool. Also, in interest of time, I will see any questions from the audience. Do we have any questions, audience? Prakash, are you there?
Yeah, I can ask a question. So, okay. Thank
Do we
you
have?
For the
we are on time, or we are?
No, we are on time. No problem.
Okay. Any questions we can take now?
Yeah, one simple and easy question. Probably, people say software edge, hardware, and then so on and so forth. So, is edge going to eat the cloud? And following that, is that going to be through Kubernetes as the baseline for infrastructure? And anyone can pick up. One can answer one, the other can answer other. This two-part question. Yeah, thanks.
Yeah, I think Sunku works on Envoy and things like that in Istio. I mean, service mesh, another thing, right? Kubernetes, probably you are the guy.
Sure. Yeah, I can start off with that. No, so I work both on OpenStack and Kubernetes, right? So I think the biggest challenge or biggest benefit here moving towards Kubernetes is, fundamentally microservices be able to deploy like chunks of your applications so that even if one part fails, you have that enough resiliency and scalability that, microservices are easy to spin up. Now, having said that, now in production, if you look at it, there are definitely thousands, millions of VMs that are in production today. Now, how would they move? How fast and how well can they evolve? Now, that is one of the biggest challenge, right? So it's not easy to disaggregate an entire application that's running on a big fat VM into like 1,000 microservices. And that's one of the biggest barrier in terms of adoption. But then, it's a industry as a whole has definitely seen the value of and ease and simplicity of leveraging something like Kubernetes to manage your containers. And there are a ton of the whole reason is it's modular, pretty much modular in design. You can it's like a Lego pieces. You can bring in your own Lego piece and have a custom resource definition and then run it and control it in your own way. Right. So yeah, you can bring in your own hardware, software piece, or whatever the case might be. And that's the best part about leveraging something like Kubernetes, where you can build Legos together. Now, the mindset and the way you use it and how fast you embrace it, I guess that's where it has to change. And it is going that way, definitely. All right, so Kubernetes now have a way to control virtual machines, right? So why? Because
It
like
can, you can
VMs are
do, you
still
can
being used,
provision
but then the
anything from
future
Kubernetes.
definitely,
Yeah.
exactly, the future definitely leads towards that.
Yeah.
Now, having said that, how would it sit with cloud and edge? I guess like it kind of touched, right? So Kubernetes definitely would be ubiquitous across these different deployment models, in my opinion, and how fast you leverage it and how you customize it based on the requirements. For example, telco requirements, there's still a lot of work being done in defining a cloud native function or an edge native function, and how best can you deploy it in the cloud. In terms of service meshes, it need not satisfy a lot of telco requirements because it's built for web services type applications, but it's kind of like the data plane for these microservices. And there's work going on towards bringing it towards telco applications, right? So there's still work to be done towards leveraging it for telco applications, but then it's kind of no-brainer to look at it as that microservices and Kubernetes is kind of the leading orchestrator here.
Okay, good. Anybody else want to add on to that?
Yeah, I think so. I think Sunku brings up very good points, right? So I think to answer also to Prakash, right? So if you look at a recent study that Gartner did, right? Gartner research, they said that the proportion of data that is generated by enterprises, right, that will be handled outside the centralized data center will go from 10% in 2018 to about 75% by 2025. So just imagine 75% of the data that is generated by the enterprise by 2025 will be processed outside the data center, right? So they'll be dealt, so they will be processed outside, and they will be the, at this point of presence of edges. And, to Sanku's point, right? So this orchestration, the ability for us to orchestrate workloads, on these locations, through a network of distributed computing will basically, that's the way you will be able to basically meet the requirements, of data processing going forward. So, so clearly there will be a existential, issue. It's like similar to how, you had a large computer, replaced by a personal computer, and now, replaced by a iPhone on your device. The kind of a trend you will see where edge computing is going to be, taking out most of the stuff that is happening. So you will be able to get a power of, you put like, 7 edge computes together, you'll get an equivalent, capacity, processing capacity, right? Of what you. So I think that is the trend we will see, And you will see this, the end. See, if you look at autonomous vehicles, so there was a case mentioned about vehicle to cloud, right? So because of these, if you look at a autonomous car, that is an ultimate mobile machine, right? It can pack itself with a lot of compute, and it can do a lot of stuff there. So I think so I would see, I definitely agree that going forward, but as you said, these processing, whether we're processing containers, or whether we're processing or even looking at these functions, not even look at serverless. That is going to be how the thing is, that you basically you come in, you use the resource, you leave the resource, and then it's available for somebody else to use. So that's the way it will be, so that's why the role that AI ML will play in terms of, managing these computes optimally and providing the orchestration, which is smart, which is basically bringing you capacity when you need, right?
Cool.
That's the kind of thing we'll see.
I think we have a few more minutes. I will give a chance to Prem to give quick comments on what do you think.
Yeah, sure, Krishna. I think Deepak and Sunku nicely summarized. Right? But one other important thing what I want to add is microservices architecture is the key thing that drives it, right? And more so, I call it as composable components, right? What is meant by composable components is you are having everything all software in as like a Lego blocks, and you compose depending upon what the requirement is. Right. Because we in a virtualized VNF for a physical network functions, right? It's one box. Whether you use 80% of the features or 20% of the features, it doesn't matter. You need to instantiate it and then start using it.
Yeah.
But now with Kubernetes and then microservice architecture, you will be able to just build what you want, like an a la carte, right? You just build what you want, and what it means is indirectly it improves the efficiency, and it also provides a customized service, right? That in a way is a key driving factor for edge adoption, is what I feel.
Okay, cool. I think we are right on time. Anybody wants to quickly say something? Otherwise, I think we are on time, Prakash. I think so. We are on right.
You are on time, and thank you for the entire.
Thank you everybody for joining, Prem, Deepak.
I will just close the recording on this, this, and start the session soon. So if you want to attend, please go ahead. And what do I do for record closing? Is there any? Can you?
I think you are the host, so you should be able to close it.
Let me see.
I was just moving.
So there is a stop record.